Moving right along, so I want to find the exact value given one value. So I'm given the sine of theta is 1 over 3, and the sine, so the cosine, is negative. Well now, so let's see what I can put together here with some ink colors. I know that the sine is y over r, and so I know the sine is positive, so I know y is positive, so I'm either in quadrant 1 or quadrant 2, but cosine is negative, so that tells me I'm in quadrant 2. So I have a point here, so I have some pretty good circle. I have my circle here, and I have a point where my radius, I know, is 3, and my y value, I know, is 1, and I just need to find my x value. No problem, Pythagorean, right? So I'm going to do my x squared plus y squared equals r squared. I'm looking for x squared. I know y is 1, and I know r is 3. So I get x squared plus 1 equals 9, x squared equals 8. I'm going to take the square root. Now notice my x, my cosine, I can already see over here, has to be a negative. So we always talk about when you square root, you really should be doing plus or minus. Well, which one is it? Well, in this quadrant, it's minus, so that's why that's important. And then I can break down this square root into 4 times 2, and then of course the square root of 4. I can bring that outside as 2, and I get that. All right, so I know what y is, I know what r is, and now I know what x is. So let's bring up another slide here, and we'll just rewrite some of this stuff so I have it. So my sine was 1 over 3, which is my y over r. We just found x. As you're going to see, I'm going to plug this into my cosine. We just found that that was the negative 2 square roots over 2, well, over r. So that would be my cosine. Then if I wanted to find the tangent, remember the tangent is y over x. So in this case would be 1/3 over negative 2 square roots of 2 over 3. Of course, the 3's are going to cancel, so I'm going to have a negative 1 over 2 square roots of 2. I'm going to multiply top and bottom by the square root of 2, just rationalizing the denominator. So I end up with a negative square roots of 2 over 4, right? Because that becomes 2, and then multiplied by that 2. All right, so now I can find all the other ones. So I have the cosecant, which is r, I'm not doing a unit circle, over y. So 3 over 1, or just 3 in this case. My y value was 1. All right, and then my secant, which will be r over x. R is 3, and x is this big mess, 2 square roots of 2, negative 2 square roots of 2. And so once again, if I want to make that look a little better, I get negative 3 square roots of 2, 2 times 2, And so negative 3 square roots of 2 over 4. And then finally, last, I have my cotangent, which is x over y. And x again was that. And y was, what was that? So negative 2 square roots of 2. All right. Now, this is how we've been doing these. Once we found our x, our y, and our r, we set all these up. What I would get into a habit of doing is use identities. So if I use identities, then I remember this identity, sine squared theta plus cosine squared theta equals 1. Remember I told you that's a very important one. Well, they told me sine was 1/3. So plus cosine squared theta equals 1. So of course that becomes 1/9 plus cosine squared theta equals 1. When I subtract it, I get cosine squared theta 1 minus 1/9, or 9 over 9 minus 1/9. So that becomes 8/9. And now when I take the square root, once again, this is the only trick I have to remember. They told me the cosine was negative. And then, of course, I can break down the square roots. And I get my 2 square roots of 2 over 3. So I get the same answer. So using the identities is a really nice way to do these. And then, so to find tangent using the identities, I just simply take sine over cosine. So I know sine is 1/3, and I know cosine is that value. All right, so once again, of course, the 3's cancel, so I have this where I'm doing the same technique as I did earlier. And I get negative square roots of 2 over 4. And I could continue doing these, then I could say, well, cotangent is actually, I could either say is cosine over sine, or I could simply say is 1 over the tangent. So in other words, just flipping it. I probably would look at this step right here, because that would be very easy to flip. And I get that for cotangent. Okay, so be sure you realize what I mean when I'm flipping these. I'm doing 1 over that value. Then going up here, let's come over here and do secant, which is 1 over the cosine. So in other words, I go find the cosine wherever it is, and I just flip it. So that's negative 3 over 2 square roots of 2. And then, of course, still having to do this business here. Over 4, don't forget my negative sign out there. And finally, cosecant, which is 1 over the sine. So I'm just flipping the sine. Well, the sine was 1 over 3, so simply would just be 3. I would get used to using identities because it makes you remember and recognize these identities. And there's a whole section on trig identities, and students normally struggle because they forget them. And so instead of using this business over here where we use the y over r, there's nothing wrong with doing it this way, but this gets you more comfortable with using identities. All right, so then next item up for bid is we talk about even and odd properties. This was mentioned when we reviewed at the very beginning of this course that said we know a function is even if you plug in a negative value and you get the function back. Okay, so a negative input. This one you plug in a negative input and you get a negative output. So by actually looking here, if I look at the sine, okay, so sine of some angle, notice that if I do the negative of that angle, I end up with the negative y. right? So in other words, what's the sine of theta? Y. What's the sine of negative theta? Negative y. And so doing the same thing with cosine, cosine being x, notice that when you do the negative, the x doesn't change, right? You're still at the same x. So, and so these are nice, very nice properties. A lot of times when you have a negative inside here, what do I do with it? In this case, you can just bring the negative out. In this case, the negative goes away. So we can certainly see by this definition that a function is odd. So my sine's odd and my cosine's even. Using identities, I can find all of these based off of sine over cosine. So if I have a negative in here, remember the sine, the negative comes out. The cosine, the negative goes away because it's odd over even. So I end up with an odd negative tangent. Cotangent, same thing, but I'm going to actually use 1 over tangent. So 1 over tangent, I already just saw that when the angle is negative, the negative comes out, so I get the negative. The secant, notice I use my 1 over cosine identity. Cosine was an even function, so the negative goes away, so secant's even as well. And then finally cosecant is 1 over sine, and the negative comes out, and so I get a negative, so cosecant's odd. So as you can see, the only even are the cosine, and then what goes with cosine, 1 over secant, okay? And so these are my only even ones, and then all the other functions are odd. So we might want to solve actual problems by these even and odd properties. Well, let me get my pencil going here. Spend more time looking for my pencil, huh? Ink color. Let's go green. Money. We ain't done green in a while. And so based off of those properties, then this says I can pull the negative out front and just find the sine of 45 degrees. Do you remember what the sine of 45 degrees is? Sure you do, because that's the easy one. That's the square root of 2 over 2. That's where the sine and cosines are the same. Looking here at cosine, we say because it's an even function, so it's just the cosine of pi. And you remember what that is? -1. The cotangent, so we already know that cosine and secant are the only ones that your angle becomes positive. So the angle comes outside. And so notice what I do here, because I don't know what the cotangent of 3 pi over 2 is. Keep my negative out front, but cotangent is the same as cosine of 3 pi over 2 divided by the sine. So see how nice those identities work? And so if I look up the cosine of 3 pi over 2, what am I looking for? 3 pi over 2. Remember I said a lot of students just seem to prefer thinking in degrees. That cancels 2. So 270. If you look and you're looking on your unit circle and you're at that point at 270, what's the x value? I think it's 0. And then let me put my negative out front. And then my sine, so in other words, this point right here would be 0, -1, and then my sine would be -1, and of course that would equal 0. The last one here, the tangent, we know we're going to pull out the negative because the tangent is an odd function. And now from here is where I'm going to do that whole deal where I'm going to use my periodic properties. So don't forget my negative. I see that 4 goes into 37 9 times. Okay, so in other words, 9 times 4, 36. So 9 pi, and I said 36, so there's 1 pi over 4 left over. Okay, again, I kind of did this, I think it was the last video, last lecture, or the one before. This is the same thing as saying 36 pi over 4 plus pi over 4. And that's how I got that. the tangent, do you remember the period of the tangent? Do you remember? It's pi. So in other words, 1 pi, 2 pi, 3 pi, 4 pi, 5, 6, 7, 8, 9 pi. I'm just basically looking for the negative of pi over 4. And once again, remembering that the tangent of pi over 4 is 1. So we get negative 1. All right, whew, that's a doozy. So guess what? That ends that section. We did a great job. We survived. Let's keep moving forward, but be sure you're getting down. I would probably say at this point where I see students struggle, even in odd properties, and then this periodic properties. Okay, so be sure you're getting these down. And as always, if you're not asking me questions, then whose problem is that, right? Is your problem. So if you need help, contact me.